So this video is intended for people completely new to programming who just want to learn some of the basics of Python. If you're unsure of how to get set up in something like this, some sort of IDE, text editor, some kind of environment where you can write and run code, check out my other video called Where to Code, How to Get Started in Programming. So let's start with the most famous example, the first thing that anyone learns in programming, print hello world. So what this is doing is it's calling a built-in function in Python called print, which will print whatever you give it here in the parentheses to the screen. We see hello world down here because it printed that. And I can put this in single quotes or double quotes, either work, and it'll work the same either way. But if I get rid of the quotes, I'll actually get an error. And that's because with the quotes, this here hello world is a string, and a string is a type in Python, and it represents some like series of characters or words, any kind of words that you want to write, and the interpreter will just take them literally as you give them to it. So there's a few different kinds of types, these basic types that are built in. There's the string, as I mentioned. There's an int, which is an integer, any whole number, 1, 2, 10, 20. There's float, which is also a number, but it's like a decimal number. So something like 4.3 is a float. And then a bool, which stands for Boolean value. And a bool can be either true or false. And that's what a Boolean is. So what did it try to do here when I got rid of the quotes? Well, if I try to just print hello without quotes, I get a name error. Name hello is not defined. And that's because it's expecting hello to be some variable name. So what is a variable? Well, let's say x equals 5. So here I'm assigning the name x to the value 5. And 5 is an int, like I mentioned above. And actually, I'm going to keep these up here, and I'm going to write them as comments. And a comment is denoted with a hashtag in front of it, and that just means it will be ignored by the interpreter. You can write whatever you want here as a comment, and it just won't be part of your program. So this 5 here is an int, and I'm assigning the variable name x to that value 5. So if I print x, I can see that it prints 5. But if I put x in quotes, it prints literally x, because this is a string. So now it's taking this character x literally and just printing it, rather than this variable that I've assigned up here. So again, if I just print x, it'll say that. And I can actually assign x to the character x and then print the variable, which will print this character x. But I can also assign it to any other string, like hello world, and I get hello world. So that's how variable names work, and those are some of the basic types in Python. So let's talk about functions. What is a function? Well, a function is just something that takes some input and returns some output. It does something to that input and then returns some new output. And it doesn't have to be a different output, but generally that's what a useful function does. And so I can say def add. So I'm defining this function called add here, and it'll take two inputs, x and y, and it'll do something with them. So if I say x plus y, and I run this, it works. I didn't get any errors, but I also didn't see any output. It didn't actually do anything. And you might think, well, okay, you have to print x and y. And even if I do that, it still doesn't do anything. Like, we don't see anything. So why is that? Well, here I've defined this function called add, and what it's supposed to do is take two numbers, x and y, and print their sum. But all I did is define that function. I didn't actually call the function or invoke it. So if I want to, down here, actually run the function add on these values 3 and 4, I see 7. It worked. It ran add 3 and 4. So what's happening here is it's running this, it's going up to the function definition, and x and y are just, again, names, variable names. I can call them whatever I want, call them hello or world, but then I have to, be referring to those variables down here. And that still works, but if this is x and this is y, it'll no longer work, because these have to be these up here. And so, I can name these whatever they want, but they will refer to whatever gets passed in when I call this add function down here. And these are called parameters or arguments, depending on the naming convention in your language. And you can have 1, 2, as many as you want. So let's try something more interesting here. What happens if we, let's say, assign add 3, 4 to the value z? So what this should do is take the value 7 and put it in z. And then we can print z. Although you'll see that something interesting happens here. It prints 7 when we call z equals, if we get rid of this print, it prints 7 because it calls add, and add prints the sum of x and y. But if we print z again down here, it's none. So why is that? And actually, if we wanted to do something even more interesting and say add 3, 4 to 10, you'd think, well, now we're adding 7 to 10. We're calling the result of add 3 and 4 inside calling add again. But this actually doesn't work. And it's not that there's any problem with doing this. The problem is in this print statement. It's because this function add is printing the sum of x and y, but it's not actually returning that value. It's not giving that value to whatever wants to use it. And so there's this nice keyword in Python, return. So now we can have this function add return the sum of x plus y. So now this actually does work. We get 17. And if we want to go back to z equals add 3, 4, now we can print z. And you'll see this difference here between out and before we saw out 7. And that just means this block of code here is this is the output of this code because we're adding 3 and 4. But we could also instead just print it, and we see it here. And again, we could print this plus 50 and see what that does. 57. Cool. So we've defined a function. We've called it. We've actually called it here inside calling it again. So that's kind of interesting. Now let's define a new function called multiply. And this again will take 2 inputs, x and y. And you might think, okay, let's return x times y. And yeah, that does work, but it's not actually that interesting. I mean, this is just, this is already something that's built into Python. So defining a function multiply that just returns x times y is not really that interesting because you could just say x times y. Same with this up here when we did add. So maybe let's make multiply a little more interesting. Let's try to define multiply using the add function that we defined up here. So how can we do that? Well, when you think about what multiplying two numbers means, let's take 3 and 5, for example. If we multiply 3 times 5, what we're saying is we want 5 3s. So we're adding 3 5 times. 3 plus 3 plus 3 plus 3 plus 3 equals 15. So we can just call our add function on x and y. Well, not on x and y. We can call it on x some number of times, namely y times. But that's actually kind of tricky unless we use a new tool that I'll introduce now called a loop. And there are a couple different kinds of loops. There are for loops and there are while loops. So let's start with the for loop. It's a little easier and more straightforward. So we can say for I in range x, total equals add total y. Well, actually, let's be clear about this. And I'll say total equals 0 up here, and I'll return, total down here. And then if I call multiply, whatever two numbers I want, let's stick with 3 and 5, I get 15. So it works. So what happened here? So here, I'm just taking this variable name and assigning it to the value 0, which is an int. And then I'm going and creating this loop. So what does this line do? Well, there's a couple things here. First, there's this range function, and this is a function just like add was when we created that one, and it's built into Python. And what it does is it takes some number and it creates basically like a list of numbers from 0 until that number exclusive, or basically 0 until that number minus 1. So if x is 3, in this case, it creates sort of this list of numbers that is iterable. And what that means is we can iterate over each of these numbers using this for I in syntax. And I is also just a variable name. So we can call I whatever we want. We can call it yellow, and it'll still work. In this case, we're not actually using this variable, but if you want to see like what it is, based on this loop syntax, we can print yellow and see that it is actually 0, 1, and 2. So what this loop is doing is it's saying, okay, for yellow in the range from 0 through 2, let's execute these lines here for each of those values. So it's important to note here, the tabbing, the spacing here is actually important. In a lot of languages, spaces are null, and it doesn't really matter. But in Python, it does, because that's how the interpreter knows that these lines are inside this loop. And similarly, that's how it knows that all of these lines are inside our multiply function. And then this, when we call multiply, notice it's not indented, it's outside our multiply function. So when we print yellow, we're seeing that it hits this, it starts with total equals 0, then it hits this line. Then, that means this first time yellow is 0. So when we print yellow, we see 0. And what we're going to do is take this variable. We could call this something new, but we're going to call it total. So this is just some name that we're assigning to the value of what total was, and it was 0. And then we're adding it to y. So we're saying total is going to equal the old value of total plus y. We're basically updating to a new value of total. And we can actually replace this with our old add function. And it still works. And so if I print total here, you can see that, total starts at 0. Then we hit this loop. Now total is going to equal total. We're adding total and y, which is 5. And when we print total, we have, 5, because that's 0 plus 5. And yeah, so x and y are 3 and 5, because when we call multiply, we're passing in these values 3 and 5. So this will equal whatever value is passed in here first before the comma, and this value will equal the second one passed after the comma. And we can call them whatever, again, hello and world, but then we have to refer to those names down here. Cool. So let's look at a while loop now. And for the while loop, we are going to need a new variable called counter. While counter is less than x, and let's say counter equals 0, and we can keep this line how it is, and whoops, so I just did something interesting. So it's important to actually update the value of counter in order for this to work. So what it's saying is, while counter is less than x, this here is a Boolean value. This is either true or it's false. Is counter less than x? Well, at first it is, because counter is 0 and x is 3. So, this is true. And so while this is true, we're going to go inside the loop, and we're going to, say total equals total plus y. We're going to increment total by y. 0 plus 5, total is 5. And then we're going to say counter equals counter plus 1. So counter was 0, so 0 plus 1, now counter is 1. So if we print counter, see 1, 2, 3. And actually, if we print counter before, now this will basically be equivalent to I in our for loop, 0, 1, and 2, and we can see that. So it was important that I added this counter line down here, this line that increments counter by 1. As you saw, I had to press stop and interrupt my kernel. And the reason for that is because if I don't include this line, counter will stay at 0. And if counter stays at 0, this will always be true. And if this is always true, our loop will never end. So we have to actually change the value of counter inside our loop. Otherwise, this will just continue to be true and our loop will never end. And that's called an infinite loop. And if you don't interrupt it, it'll just keep going. And so that can be kind of annoying and something to try to avoid. But you also might see sometimes in programming, someone might write while true, and sometimes it's actually intended behavior for a while loop to always run as long as your program is running. But in general, you want some kind of counter or something that updates inside your loop so that the condition is not always true. So that's our multiply function. Now let's do one final exercise here with conditionals. These are if-else statements, and they're pretty important for the logic of programming. So if we say like x equals 5, what happens if we print x is less than 5? False. So this is a Boolean value. Like I said, a bool is either true or false. In this case, this evaluates to false because x is not less than 5, x equals 5. But if instead I say x equals 5, I get true. And the reason I have to use this double equals here is because the single equals is set aside in Python as the way to assign a variable to a value. And this is true in basically all languages. The single equals is to assign some variable name to some value. And so if you want to actually see if two things are equal and use more of the comparison type of equals, you have to do double equals. So let's try something here. If we say if x equals 5, print x, let's print a string, x is equal to 5. Cool, so we see that we printed our string here. And if we add something like this, elif x less than 5, we can print another string, x is less than 5. And we can also have an else statement that says, well, if x is not equal to 5 and x is not less than 5, then x is greater than 5. So now if we change the value of x here to 4, we get x is less than 5, x is greater than 5, or x is equal to 5. And one thing to note here, elif, if you just made this an if statement, it's actually a little different. So now we actually see different behavior. And that's because if you just have two if statements next to each other, there's no relation between them. It'll just see if this is true, and if it is, it'll execute this code. And then it'll move on and see if this is true and execute this code. But if you use an elif, it'll see if this is true, and if it is, it'll execute this code. And then if that first if statement was not true, then it will check this statement. And if that's true, it'll execute this code. So the reason that it prints both of these here is because this if sort of broke up this string of statements. This else is now the else of this if rather than the else of the whole if elif like branch. So it said, oh, if x is less than 5, print x is less than 5. And that was not true, so then this else becomes true. Because this was true, so it printed this, and then it like did a whole separate if else down here. But if we do elif, we can see it does what we expect because it's looking for each of these three conditions. So there you have it. Those are sort of the very basics of Python, and really they can be translated to just about any language. You've got your basic types. You've got like a print statement, which can be super useful. You've got function definitions, declarations, and then actually invoking those functions and the difference there. And then you've also got while loops, and we also covered the for loops where we said for I in range, and then we wrote some code. And then down here, we looked at our conditionals, which take Boolean conditions, just like the while loop did. And then, based on how those evaluate, it may or may not execute the code inside them. So I hope this video was helpful, and thanks very much for watching.